Well, hello to everybody once again. It is definitely not 1 a.m. yet, which is awesome. It is 12:32, and I am doing phenomenal. I'm happy to hear that you're with me. Fun fact, for the AP classroom yesterday, it seemed like I didn't assign it to sixth period, so cool. Sixth period, this one is for you. Congratulations on dodging a bullet there. Here we go. This is question number 1 on the AP Classroom from Verifying Solutions to Differential Equations, which was Thursday's homework. Okay. dy dx equals y secant squared x and y equals 5 when x equals 0. So I'm just going to take this part. That's your initial condition. And that is 0, 5. Okay, so we have a 0, 5 for a... sorry, just looking over things. We have 0, 5 for our initial condition. The first thing I actually do is I like to test the initial condition of each of these and see if I actually get 5 out of any of them. So for instance, when x equals 0 here, do I end up getting out 5? And when x equals 0, tangent of 0 is 0, e to the 0 is 1, so I do get 5 out. However, if I plug in tangent of 0 in b, e to the 0 is 1, 1 plus 5 is 6, b is out. And I always use that initial condition just to test and see what's going on. I looked ahead for you, and everything else will yield 5. So only one of those was false for that initial condition. Second, let's look at this part. So dy dx equals y secant squared x. dy dx equals y secant squared x. Secant squared x, there we go. There we go. Okay. So let's separate the variables. So we have 1 over y dy equals secant squared x dx. I forgot my writing utensil at work. So my writing has been particularly bad. Okay, let's integrate both sides since variables are separated. Antiderivative of the left is natural log absolute value of y equals antiderivative of secant squared x is tangent of x plus c. Let's go ahead and plug in our initial condition here, which was 0, 5. So now we have the natural log of 5. Oh my gosh, are you kidding? Natural log of 5 is equal to tan of 0. Wow, this is horrible. Plus c. Tangent 0 is 0, so c equals natural log of 5. Hooray! So now you can take that fun fact and go and plug it back in here. So natural log of the absolute value of y equals tangent of x plus natural log of 5. Hooray! And now we need to drop the ln to solve for y. So we're just going to do a fancy term here called exponentiate. And if you're not sure what exponentiate is, it's basically raising everything from before and making it an exponent with some base on the bottom. E to the ln, that allows you to drop the base. Drop that base. And we're going to get absolute value of y equals e to the tan x plus ln of 5, all in the exponent. And I don't know if you're aware of this property. I know you are, actually. I'm not going to say that. I know you are. That means the absolute value of y is equal to e to the tan x and then times e to the ln of 5. And the reason we can do that is because that's a property of exponents. X to the a plus b equals x to the a times x to the b. So, since these two are true, that's all I did from here to there. And the reason I did that is because, oh, is that a 5? Oh, horrible. I can drop that base here. And this 5 goes right in front. So my answer is going to be a y equals 5 e tan x. It is a positive because e is positive and 5 is positive. So there can be no negative values here. So 5e tan x, that's C. C is the answer. I hope I'm right. Let's see here. I really hope I'm right. Let's go to the third period. See, look, sixth period wasn't assigned it. So depressing. Let's go here, though, and see. I hope number 1 is C. I'm really wasting time here because I know number 1 is C because I did all the work correct. So move it along, AB Classroom. Move it or lose it. Oh my gosh, C is the answer. What? Okay, now let's go on to number 2. All right, number 2, and let's see if I can write better here. All right, here we go. So if I plug in 0, negative natural log of 4, I'll let you try that. One of these is false. Because if you try to plug in 0 to one of these ends up not giving you negative natural log of 4. And that's E. And why would I take the time to do that anyway? Well, if I wasn't sure on the test, I can increase my chances of getting the answer correct if I eliminate one of the wrong answers, right? Right. Okay, so now let's go ahead and solve this one here. So I got e to the y plus x. Ooh. Okay, well, let's go ahead and separate and integrate. Well, let's rewrite that that right side. It's e to the y times e to the x. And then let's go ahead and separate the variables. So we have 1 over e to the y dy equals e to the x dx. And now let's go ahead and integrate these bad boys. And on the left side, we're going to get on the other left, we're going to get e to the x plus c. On the left side, this is integral of e to the y, but the integral of e to the y dy, the integral of 1 over e to the y dy is the same as the integral of e to the negative y. And if you did a u substitution, if you needed a u equals negative y, you would find out that you would need a negative here. And again, you may not need this step, but I'm just showing all the steps in case you were unsure. Which means that this integral is now negative e to the negative y. And we don't need a constant integration because it's on the other side. So negative e to the negative y. Okay, let's go and plug in our point, 0, negative natural log of 4. So negative e to the negative natural log of 4 equals e to the 0 plus c. And if I remember correctly, e to the 0 is 1. So let's see what happens here. We got a negative e to the natural log of 4 equals 1 plus c. And because we have e to the ln, we can drop that base. And get negative 4 equals 1 plus c. C is negative 5. Hooray! Okay, so now let's go ahead and solve the rest of the problem. We're going to take that apart and go divert. Zoom. And we will get negative e to the negative y. I'll do blue now. Blue's a nice color. Negative e to the negative y equals, oh gosh, this no pen thing is killing me. That's not helpful. Okay, let's try that again. Negative e to the negative y equals e to the x minus 5. Okay, let's go and divide by a negative. So we're going to get e to the negative y equals negative e to the x plus 5. And now let's go and ln both sides. This is Kayla Gottschall's favorite thing to do. So let's ln up both sides. So I'll just do a little ln here. Doink ln. Doink ln. Okay, and we get that negative y drops down to the front. ln of e is cancels, that's 1. So we end up getting out negative y equals ln of negative e to the x plus 5. And to solve for y completely and put us out of misery on this problem, this is our answer. And it looks like that answer is going to be C. Hooray! Okay. Let's go to number 3. Number 3. Okay, a curve has a slope of 2x plus 3 at each point. Well, let's see. What do we do with that piece of information? A curve has a slope of 2x plus 3. Well, if it's at each point x, y, that sounds like a derivative. So y prime equals 2x plus 3. And then it says, which of the following, if the curve, the original curve, passes through 1, 2. So what that means is I need an integral then to find what the original curve is. So the integral of y prime is y. Integral of 2x is 2x squared over 2, or just x squared. And antiderivative of 3 is 3x. And don't forget, communism. Okay, now let's go and plug in 1, 2. So now let's use that information to just get what c is. And we're going to get... Now, notice, by the way, I didn't actually plug in 1, 2 here. If I did, because I gave you that strategy for the past 2 problems. If I did, it looks like it would be... C is out. And 2, 5. Okay, so that's all. You could, if we were doing some test-taking strategies here, you could eliminate e, because you would need a positive 2x squared. And you could eliminate this one and that one. By the way, this one definitely doesn't work. Because how could the slope be 2x plus 3 for every point on the curve if your line is always going to have a slope of 5? Does not make sense. No entiendo. I don't understand. So now let's just get the actual answer for D by plugging in 2 and 1. Okay, so now we're going to get 2 equals 1 plus 3 plus c. It looks like c is going to be equal to negative 2, and that gets me D. All right, number 4. For what value of k, if any, will y equals that be a solution to the differential equation y double prime, blah, blah, blah. All right, not really sure where to start. No, I need to solve for k, so that's helpful. So how do I solve for this value of k? Well, there's no test-taking strategy I can think of off the top of my head, but I can do find y double prime, because I'm not given that. So let's find y double prime. Y prime is equal to k times cosine of 5x, taking the derivative, and then times 5 for the chain rule. And then it's going to be the derivative cosine is negative sine, so negative sine of, keep the argument, and then multiply times the derivative of the argument by that 2. So we're going to do minus 2 times 4, which is minus 8. And let's do it one more time. Y double prime is equal to, again, it's going to be negative sine of 5x. But now we're going to multiply this 5 and that 5 together to get 25. And the k is still there. And now let's go on and do minus, derivative sine is cosine of 4x. And just to do the chain rule here, we'll multiply that 4 and that 8 to get a minus 32. Okay, I got y double prime. Now what it says is that if I add 16y, so let's go and add 16y. So we're going to add 16y, which means that we're going to add 16 times this y. So 16 times k sine of 5x plus 2 cosine of 4x. Okay, so let's see what I have here. Please notice, and this is the most important part of the problem, that there are huge parentheses here. Massive parentheses. So let's add vertically as if we were doing a system of equations. We would have negative 25k sine x, and then we would do plus 16. Negative 25 plus 16 is negative 9. So we get negative 9k sine of 5x. And many students will say that negative 32 plus 2 is negative 30, but it's 16 times 2, which is 32. And the 32 cosine 4x and the negative 32 cosine 4x, those cancel. So you're just off with that part. The other side of the equation is what was given to you. Negative 27. Let's use a fun color. So now let's set this equal to negative 27 sine. Gosh. There we go. Okay, so equals negative 27 sine of 5. Glad this is only 5 problems long. All right. Since we have sine 5x's on both sides, see ya. And that gives us k is 3. Okay. And then for the final one, okay, of the following, which of the solutions to the differential equation y double prime? All right, well, let's see what we got here. I think we just have to do each one, so let's do the first one in black. Y double prime is, let's see, y prime is 6 cosine of 3x. The reason it's 6 cosine is because you had to multiply the 2 and the 3 for the chain rule, and derivative sine is cosine. Y double prime is, again, the 6 times 3 is 18. It's going to be negative sine of 3x. So now let's add these and see if we actually get the answer we want. When we do y double prime, so negative 18 sine of 3x minus 10. Minus 10, so that's going to be minus 18. Minus 10 times 6, which is minus 60 cosine of 3x. And then plus 9 times 2 sine 3x, because y is 2 sine 3x. So plus 18 sine 3x. Does this equal 0? And because I'm struggling writing things out, those cancel, but that middle part is not equal to 0, so 1 is a big no. So let's try number 2. All right, number 2, I'll do in green. All right, let's do y prime. That's equal to 5 e to the x. Y double prime is 5 e to the x. That's a little bit easier. Okay, that's a 5. All right, so let's subtract these. We get 5 e to the x. So again, I'm doing y double prime. So 5 e to the x minus 10 times the 5, so it's minus 50 e to the x. Gosh. And then we're going to do plus 9 times, again, what y is, which is 5 e to the x. So that's going to be 45 e to the x. And I'll save you the suspense here. They're equal. That equals 0. Hooray! So 2 works. So now let's do 3. 3, it says where c is a constant and we don't know what that constant is. So I'm going to erase this part just to give myself some room here. If you need to see it again, it's in the video. How clever, Mr. Lakin. Okay, I'm on 20 minutes already. Gotta speed this up, Mr. Lakin. Alright, y prime is equal to 9c e to the 9x. The reason it's 9c e to the 9x is because the derivative of e to anything is e to anything times the derivative of the exponent. And that's why there's a 9 down at the front. Y double prime is equal to 81c, and it should be a capital C in both of these. E to the 9x. So now let's test the equation. We need 0. So 81c e to the 9x minus 10 times 9 is 90, so minus 90 c e to the 9x, and then plus 9 times c e to the 9x, because that's what y is. Okay, do we get 0 here? Well, 81 and 9 is 90, so those are out, because 81 and 9 is 90, minus 90 is 0, so we got a true statement here. Final answer, 2 and 3. Okay guys, thanks for watching. Go to sleep.